So it's getting recorded. Oh, am I audible?
Yeah,
Yes.
yeah.
Okay. Yeah, we can. So we can start then. So our first problem is for climbing the stairs. We are climbing a staircase which has n steps to reach to the top, and each time we can either climb one or two steps. So we have to find out in how many distinct ways can we do in order to climb to the top of the stairs. And note that n will be given as a positive integer. Let's say there are two steps. There are two ways. Either you can take one step, or you can directly go to the take a two step at a time. So there are two possible ways to go. And if there are three steps, you can take either one step each, or one step and then two step, or first two step and then one step. So total number of ways would be three. Okay, yeah. There are any queries in this question? Or if somebody wants to share the approach.
So I'm thinking of the top-down approach. So, you know, we either take one step down or two steps down. You know, if we take one step down, we reduce the problem to smaller sub-problem. And we take two steps down, we also reduce to the smaller sub-problem. And if we keep going down, we will see that, you know, the best case would be either going to be 0 or going to be negative. If it's negative, then we don't count it. Because, for example, if we at step 1, and then we take one step back and go to 0. But at step 1, if we take two steps back and go to -1, so we don't take it.
Yeah. Can you find some series over here? Like, yeah, the approach is good only, like DP only, but can you, is it analogous to any of the series?
Yeah, this looks like Fibonacci.
Yeah,
That
exactly.
is,
So yeah, go ahead.
you just either go one step back or two steps back and just add up the result. So you have the base cases of 1 and 2, where you can say that is how you can start. That is, if you had n equal to 1 steps, then there is only one possible way. If n equal to 2, then you could have either done 1 plus 1 or just 2. So I have two approaches there. And now for 3, I can just add the previous two to see. So at 3, I could have reached to 3 by taking one step from 2 or by taking two steps from 1. So I'll just combine the ways to reach from 1 and 2 to make my 3. Does that make sense?
Yeah, it's similar to that. I want to share something.
Actually, I haven't coded anything in the system.
Okay. Somebody wants to somebody wants to share.
I think we can try visualizing it. I can.
Sure. Okay, let me stop sharing. No.
These questions are like, this is just, I think, 1 or 2 steps, but there could be 1, 2, 3. But these questions could be always. I felt like a little tricky to visualize, but let's try that.
Yeah, sure.
So when I'm here, to reach here, I can only take one step.
Yeah.
And to reach here, I can again take one step from here to here. And from here, because he told I can also take two steps. So basically I can directly reach here and it will become 1 plus 1. 2.
Mhm.
Again, I can reach here at one step, which would be, so basically we can from here to here, and from here I can also take one step and I can reach here. That's what, if I sum previous 2, it could give me the answer, which is 3. So basically I took one step from here or from here. So how many ways it will become? It will become 3 if I'm here.
Yeah.
And similarly, if I have to reach here, I can take one step from here or I can take one step from here. So total ways would be, if I add this and this, that will become 4. No, sorry, 5.
5 I told you. Yeah.
So that's what it become the Fibonacci series.
From n equal to 3. I mean, from 3 onwards.
Yeah, 3 onwards.
Yeah, yeah. Mhm.
So that's what I have visualized. Whenever you are here, you basically, if it is 2, so we can either take 1 or 2 steps, then it will be last 2. If it is somebody say 3 also, I can take 3 steps. So basically, I can even jump from here. So basically, then it will add up last 3, previous 3, and put it here.
Yeah.
Yeah, I want to add one more point that if we are suppose at the ith step, then we want to, if we are at the ith step, then our answer at the ith step depends upon the previous answers. So
Yeah.
that's also brings the intuition of overlapping sub problems, that if we want to find out the answer of the ith step, then it depends on the previous answers. So that also brings the intuition of that if we store the previous answers, that can be used to find the answer of the ith step.
So
Yeah.
technically, if we do bottom up or top down, the formula is something like this. Oh, it's small. How to make it bigger? I don't know. Okay, so can you guys see that?
Yeah, yeah, yeah.
So we are telling to calculate Fn. I'm going Fn minus 1. So basically to reach nth step, if I take a total of previous 2, that will give my answer. Either I can take 1 step or I can take 2 steps. So basically this represent, like I take from previous 2 steps, if I take 1 step, I can reach here, and previous n minus 1, if I take, that will reach here, and the total will be Fn minus 1 plus Fn minus 2. And now it's up to us how we want to do, top down or bottom up. Like, this was my take on that. There could be different explanations, but yes, this was my take on that. So I think Shashank, you already have a code. Probably you can share.
Yeah, yeah, yeah. Okay.
Stop sharing. Is there any other question people have?
Yeah, so this one we can take, like, if we take 1 step, 2 step, or 3 step, or 5 step, for example, if that's the case, it resembles the coin change, right? Because
Similar
if we think that, the coin denomination at the step, that is exactly the same.
I'm not sure, because here we are talking last 3 things. So the coin change could have a different formula. So basically, these dynamic programming questions always have some. I have seen some formula which you have to solve. So I don't remember for the coin change.
Coin change is actually different because in coin change we have to find the minimum number of coins, right? So to get that particular amount. In that there is no such constraint that we need to find the minimum. We have to just calculate the total number of ways in which we can get to the nth step.
But there's also a problem in coin chain to say, you know, how many ways you can get to this amount. And
Maximum.
you can think, yeah, you can think the amount of the coin chain is the n in this case, the stair, you know.
Yeah, then I think it will be quite similar to it.
But that question also says you can reuse the same coin. So
Yeah.
basically, if I have 1, 2, 3, I can reuse one many times.
Yeah, this is the same, right? Because you can step one and you can step one again, you can step one again, you reuse one or two many times.
Could be, but I can't visualize that coin change here. Sorry for that.
Okay, Shashank, can you
No.
share the code?
Sure. I think. Yeah. Yeah, the concept is same what Bhumik and Hasim and Leon was discussing. So it's like these are the base cases for first and second. I mean, if you have only one step to climb, only one way, but if you have two steps, either you can directly jump, one way is that, or you can take one step. So there are two possible ways. And if you look from n equal to 3, you'll form a DP. I mean, the sequence will be like that of a Fibonacci one, like previous and previous to previous you are taking. At last, we're returning this.
So Shashank, if I give n equal to 2, would this code work?
Yeah, sure. It's for 2 only. It's
Okay.
no.
So one optimization here, it could be a variation interviewer can ask, can you avoid taking that DP array?
Yeah, since the nth step depends on the previous two steps only, so you don't need a whole array for it. You just can store it in a local variable.
Like a
Say
previous one,
DP1.
previous 2.
Yeah, so previous two states can be stored in some local variables and they can be interchanged in
Reused.
the for loop. Yeah, the for loop.
But
I can quickly share the code for that optimization. I just wrote something if you guys are interested in Java.
so interviewer, so it all depends how you can tell interviewer. I can tell like, hey, I have built the array for n numbers. If you can say, if you want for 4, 5, I have an array which from where I can pick any n now.
Okay, are you folks able to see the screen?
Mhm.
Yep, so it's the same thing which we have been discussing. I just, as you were discussing, used the previous and previous. In the base case, I have just taken the liberty of checking till 3 because till 3, it's the same number of ways as the number of steps. So no need to do any computation, and then just do a Fibonacci sequence and return this. Yeah, and all we are doing is storing just two temporary variables and using another temporary variable to do the swap.
It's starting from 4, right?
Yeah, because till 3, it's the same thing.
Yeah.
You don't really need to get into the loop or anything till 3.
No, makes sense.
Yeah,
Any questions
good to
here?
me.
Yeah. Okay, cool. I'll stop sharing.
This is exactly the same as Fibonacci.
Yes, it
Right.
is.
Yeah, that is what we're talking.
I think just this starting numbers, they differ a little bit. I'm like missing out on this. So Fibonacci starts with 1, 1 and then goes on, right? I think, yeah, if there is a 0, then Fibonacci is 1. Can't remember what exactly it was, but it is exact same as Fibonacci.
Yeah. So so I think Fibonacci again can be we also do Fibonacci the same way. So if we are doing this, already covering Fibonacci series.
That's why easy they have given, even though it is a DP problem. I mean,
But this question again comes in variation, like you can take 1, 2, 3 steps,
yeah,
or it can even come like you can take 1 and 3 only. So you can't take 2, but you can take 1 and 3 only. Then we have to tweak it. Like instead of summing up last 3, we have to sum last 1. Like
third
we have,
I minus 3 and
yeah, I minus 3 and I minus 1.
Yeah, so if that input becomes variable, I think for a generalized solution, we may even get an input of number of steps here.
Yes, yeah, it
So,
could be.
yeah.
but
Then,
in that case, I don't think so this will work. Will this code work in that case?
No,
With that
we'll
very,
have to
yeah,
do
then we have
that,
to
the
maintain
TP
the
array
whole
would
array.
be
Yeah.
the
yeah,
TP array would be good.
recurrence relation we have to form and then work on that.
Yep.
Yeah.
And it has a Fibonacci as its linked.
Related.
Yeah.
Yeah.
Cool. I'll stop sharing.
Okay. No. No. Proceed to next. Next one is like we have to find minimum cost for tickets in a country which is popular for the train travel. We have planned some train traveling in a year in advance. The days of the year that will be traveling is given as array days, and each day is an integer from 1 to 65. These are the rules for that. If a 1 day pass is sold, a 1 day pass is sold for cost of you'll be given a cost array. The first element would represent the 1 day pass, second element would represent a 7 day pass, and third one would represent your 30-day pass. The passes allow that many days of consecutive travel. For example, if we get a 7 day pass on day 2, we can travel for 7 days and they are consecutive 2, 3, 5, 6, 7, and 8. Now we are supposed to return the minimum number of dollars we need to travel every day in the given list of days. So these are the days given to us and these are the cost. If we look here, so this is the strategy how they got 11. On first day, they took $2, which helped them to cover day 1. Now remaining, then on day 3, they bought a 7-day pass, which helped them to cover from 3 to 9. And on the 20th day, they again purchased the first this 2 rupees ticket, which covered their day 20. So all in all, it was around 11. And same year, I mean, the different strategy, like day 1, they purchased a 30-day pass with a cost 2, that is 15, which helped them to cover a duration of 1 to 30. This and on last day 31st, he bought a 1-day pass for this 2 rupees ticket, and which helped them to cover the 31st. In total they have spent $17. And these are the constraints, like days are strictly increasing order here. You have days length, which is less than 65, already mentioned, and yeah, cost length is equal to 3, and this is fixed. The array will be length of 3. Okay. Yeah, any queries or approach in this?
Can you scroll back to example 1?
Yeah, sure.
So in example 1, they say they take the first day for a single ticket and the next 7 days for a weekly ticket. I see. Okay. So, but on in this example 1, we could have taken we could have taken like the first week. We buy the weekly ticket that can be $7.
Okay.
Right? We cover from day 1 to day 7.
Yeah.
Right. And day 8 we buy one individual ticket, and day 20 we buy one individual ticket.
Then it will be 13 in that case. See, on day 1, if you purchase a 7 month, so 7 rupees for that,
Okay.
And next 8 you will purchase this two. So 7 to 9, and again on day 20 you will purchase this first ticket. So
Yeah. Okay.
it will be 30, and we need to return them. Yeah.
Hold on. Wouldn't that be 11 still total? So 7 plus 2 plus 2.
Oh yeah. Yeah, correct. I, okay. Yeah, sorry. 7
I'm
plus
just debating in my mind whether greedy approach would work or not here. Like if I can somehow prove that the greedy would or would not work, that would really help to think. Because otherwise, at any point in time or on any day, you have all these three options of going with 2, 7, and 15.
greedy
And
gives
Bhumik,
a
can
good
you
instead of,
first.
can you explain your greedy approach?
yeah, so it's something like if I'm on any given day, so if I'm on day one, then for the next 15 days, what would be the most efficient way for me? So if I take 1 day tickets each, so from the day I am on, I'll go and traverse my array to find the days which are in the range of 30, because that is the range we are given, right? That I have 1, 7, and 30 days ranges. So I'll just find out the 30 days range from the day I am on, and then I can greedily calculate that what would be the most efficient way. Like, can I just buy a 30-day pass and cover all those days, or would I take all
But
1 day passes and things like that? I'm not sure. I'm just thinking aloud right now.
yeah, but for that, like the cost of pass should be like it should be lesser for the 30 days period
Yeah, it
rather
should be
than having a
for
1 day pass of 30 times.
the
But I
day
don't
can
think that,
be the day can be
that
up to 365, right? It's not like with only
yeah,
one
no,
month.
no, no, I'm just saying for if you take 1 day pass for 30 times, would it be always less than a 30-day pass?
No, no, not
Right?
really.
And
So
we don't
Yeah.
have that constraint also. So I
in the
don't, that
30-day
is,
window, in the 30-day
Dollar.
window, I may not have 30 days which I have planned the travel for, right? So that is how you
yeah,
can compute.
no, no, that is that you might not have, but you're thinking that your greedy would work, then that case is directly failing.
Okay, if it's greedy day, I would think, okay, how much would it cost for ticket per day? So in this, if we look at the cost, for example, one day would cost $2, right? But if we buy the weekly ticket, one day would cost like
7.
$0.5, right? Because it's like say $1. Seven divided by 7, yeah, it's one
Yeah, yeah,
dollar, right?
yeah.
And 30 days would cost like $0.5 per ticket. And then if we do with greedy, we go and we say, okay, which one would be the cheap way to cover all the day we need to go?
I'm not sure greedy would work, but maybe I think the generally min-max problem of DP, we can try using that. Like for a certain day, if I'm buying, then I have three options. Like if I can buy a single day ticket for that day,
You want to
what was
share?
the
I think it
I
will be
haven't
better.
written, I'm just thinking it out,
Okay.
but yeah, I can write something on notepad if like.
Okay. Okay. Sure.
But does anyone have a like better approach to share? I'm just thinking.
So
Let's
you
say.
look on the last day.
Yeah, so for that case, I'll look whatever was the cost till the last
Okay.
day. If I buy a 1 day ticket for that day. Other
Yeah.
option I would have is I can buy a 7 day pass on that day, or I would have bought a 7 day pass 7 days back. And what was the cost till like DP of, if I'm calculating for DP of I, then I would look till DP of I minus 7, what was the minimum cost plus $7 in this case. Or I can look till all the previous calculated valid days, dp of I minus 30 plus the cost of 30-day pass. But
Simar, can you
yeah,
share the screen, please?
yeah. So
Hello?
Yeah. Sound is not coming, it seems,
Yeah,
from his
it
side.
seemed like he talking, but we did not hear.
Yeah. Simmer, I think your sound is not coming.
oh, I explained everything and I was on mute. Sorry.
No, I thought I was not on the list. I mean, I was not getting, but
Yeah. So, okay, I'll just repeat. So, what I'm saying is, if we are looking for, suppose, on day number 10,
okay.
so what option do I have? So, either I have calculated the cost till the day 8, and then I can buy a single day ticket for day 10. That is one of the ways. And the second way is, if I had calculated till the -7 days, if I have paid till there, and then I can take 7-day pass, that could also be one of the answers. And I have a chance to buy, if I have a chance to buy 30-day pass, so but here I won't have, so I'll take that as 0. So similarly for day 45, we can look similar, we can buy a single day pass and calculate add the cost till 30th day.
Yeah, so but if suppose you have
But
only one element there in the array, let's say you have only 45 in the array. So
okay,
then I think this might not work.
I'm just these are the actually these I won't make the till 365, or maybe I can make, but even if you have 45, I'll iterate through all the possible days. I won't be going, if I
Yeah,
won't be filling up the 365 elements in the array.
yeah. So we have to take the like maximum element. Like this
Yeah,
is the
so
n
So I
minus
have,
1.
yeah. So I'll actually, it would be something like, so if I'm calculating for ith element, the numbers are always in increasing order. I think that's a constraint. So
Yeah.
the days are in increasing order. So I I minus, given that it is a valid I minus days of j is greater than 0, plus then I can see the difference actually, that how much lag is there if it is a 1 day lag. If I'm buying ticket, the thing I was saying over here. So I was just telling how I'd fill. I won't be filling the entire 365 elements. I'll be just filling all the arrays I have, and it won't be actually 0 to n. It would be the number of days actually.
Yeah, I
So
understood.
let's say, suppose you're on day 45, right? And then you buy the monthly ticket, right?
Yeah.
So you would track like 30 days ago how much was the best, how much was it cost? How would you
Yeah.
find it?
I'm actually storing it from behind. I'm actually calculating for 1, then I'm calculating it for 3, best possible cost. I'm calculating it for all the elements in there.
And
That
you
is
use
what I'm
the
storing.
index to track, because
Yeah, this
look
I
at
won't
this
be.
array right here, like 45,
Yeah,
and
yeah.
30 days ago it had to be like 15,
So
right?
since this is not continuous, so I think we don't need to calculate for all the days. We just need to calculate for all the valid days, on which I would be traveling. So I think Shashank can take over and share his solution, because I haven't implemented. I was just sharing the idea that we can try this.
Yeah, because for now I see 45 minus 30 would be 15, but I don't see how you track it back to the 15.
So here, if I'm I minus days of j, so I'd look into that. Is it a valid DP of I? I would mark the all others as something unreachable or whatever. I can do that way, and whatever the valid ones for which I've calculated, maybe that I can use.
What is days of j? Is that 30 or
The days of j is this.
Last day, till the day, yeah.
Actually, don't go through the pseudocode. I was just saying this is not correct. This is not the answer. Also, I was just sharing the idea that we can calculate it from some previous states that we have already computed.
Yeah,
That is what I feel. So this is not the code actually. I was just trying to write it, but this is. I think there are many bugs. It's totally wrong. I'll just delete it. So I'll stop sharing, and I think someone who has solved it can share.
Yeah, I understand your idea, but I just don't see how you calculate that. That's a good idea. Yeah.
Okay. Yeah. So I'll stop sharing.
No. Yeah. So how I would be like, I'll go through the days, I think. No, sorry, what I said. Yeah. So what I'll do, first I'll go through the days and I'll check if that day is not in my day. I mean, that particular day I'm searching for, let's say I'm searching for 3, and if doesn't live, then I'll take the minimum in that case. Which will be minimum cost of the day would be equal to your last day of the will be equal to your last day. Else, if you find that yeah, that day is in your days, then you take the minimum of these three. Like what the current day, there could be three possibilities. Like current day minus one plus cost of zero for that, for $2 ticket, or you can have current minus 7 plus cost of that is one first yeah, I mean I first index 7, or you can have current minus 30, and for this corresponding cost is cost of 2. This is just like if you don't find the day, I'll take the last days, else I'll take the minimum of all these. As he was explaining, like if you have to go for the 30th day and you are till 29, uh, you have to check for the last that current day minus 30, and subsequently add the corresponding cost to that 15. So this what I was just checking. If your day is not in that, then you take the last day as your minimum and then continue. Else, if your day is greater than take ticket, just take the minimum of these, or else you go for this.
So DP day is storing the current day's cost so far.
Yeah, current days. The days which are mentioned here.
In DP, actually, we are storing the minimum cost that can be obtained at that particular day.
Particular day, yeah. That's why I'm doing this.
You start all 365 days, or it's only the array?
I didn't get.
Do you in your array, do you store all 365 days? The the day of the year. Let me see on line 14, right? You say day minus the ticket, but the ticket could be 30. So
yeah.
whatever the day it is minus a ticket, that seems like you treat that like a continuous continuous array, right? Because on a given day, let's say on a given day is like 45 minus a ticket 30 days.
Okay.
You have the array at index 15 already.
Yeah.
Yeah, so I think the maximum days he's having the DP array of that size. So maybe it can go up to 365 days, right?
Okay.
Yeah.
In the worst case, it will be 365.
Yeah.
Yeah, any queries on this further?
So, can you explain how you're initializing the array up between 4 and 6?
Yeah, sure. Oh, okay. Yeah, this is like picking always the last days. I mean, size will be arrays like 30, whatever the last value is. Now max cost will be the maximum cost out of it take, and then multiply with the size of a days. I mean, let's say if you have a day 20 day, you'll make array of 20 and fill it with 15 15 15 maximum cost from here. And this is that DP array that I've created, 0th index and that max cost array into the size of the days, and this a dict price corresponding to 1 cost 0, 7 cost 1, and 30 cost 2, and then iterate through that DP.
So let's say you have your input only have like 30,
Okay.
only one day 30.
Okay.
Right? Or maybe 29, I think. Yeah. And then on line 9.
9. Okay.
No, wait. You make like 29 subtract 30, so that can be -1. On line 9, you say if because -1 is not in days, and then you're going to return the day before the day -1, but the day -1 is not there. You know what, you understand what I'm saying?
You're saying for 29 is not in the array, right? I mean, in the
No,
days
no,
array.
like the days only have only one element is 29. We interest in buy the ticket on one day only, on day 29 only.
Oh, I mean, days array will have an element only as 29.
Yeah.
So 20. Yeah, go ahead.
So you have to buy the ticket. You use the monthly ticket, right? That's going to be 30 subtract. Oh, but you're going to one day ticket already. Okay. Yeah. Never mind. Yeah.
It will start from 1.
Yeah.
Mm-hmm.
Can we make the DP array and see how the values look into it?
Yeah, sure. I think I'll print it only. We'll get a good format. Print here. Let's see. Initially, let me print first here. So I think this is your initial array. Wait. Just a sec. This is your initial array, okay? That we had. This one, and yeah, let me. Let me capture this. I think I printed it at a.
I think you have printed it in the loop.
Yeah, it seems like I should. Oh, should I print it inside loop?
No, this is fine. I
No,
think per day you are going through every day and you are checking the values. This is good.
Minimum value.
Yeah.
But
My question is, so if the days if day one was not there and then day 2 was there, so for the day 1 it would have costed 300. That's what you're saying. So in the array, if day 1 instead of 1 we had 2.
Okay.
Then the second on the line 25th, 0, 300, and then 2. That's what it would have happened.
Yeah, it would have been like that.
Yeah.
Because
because in the for loop you are checking if that day is greater than ticket,
than your tickets.
Yeah, then only you can do the minus and check.
Yeah.
Then why there is this else part?
Else is for if your ticket day is less than your ticket. Like, let's say you have a day, you have a ticket which is 2, and if you have a day like 1, then in that case it'll take minimum from here.
So in the test case, if you remove day 1 and if you can execute one time.
Sure. Okay.
Oh, so you are initializing them to 0.
Yeah,
You're not
exactly.
keeping it to 300. Oh.
No.
Okay, good. Thank you.
Yeah, actually the part where he's like, if the day is not in the like part of the day's array, so he's taking the previous value. Initial value is 0 for the 0th element, so every element would be 0 till we don't have a travel day.
The value.
Yeah, that
that's,
I think that is important, because I was thinking,
Yeah.
how come it is taking 300,
Yeah, so
and
even
then
I also
yeah.
like my code also I was stuck.
yeah,
Like,
that's
so
line
we
10,
have to
11, 12.
iterate
Yeah,
through
I
all
think
the
if we in the DP array instead of 300, first we initialize all the elements. It will be basically a binary DP array. In the sense initially that it will store like if it is a travel day, we can mark it as 1, else it will be 0, and then we can update the DP array according to the cost. So we can like check if the value is 0, that means that is not a travel day, so it will be the value equivalent to the last minimum value which we have got on the last day. Otherwise we can take the minimum out of the 3 possibilities.
Yeah, this one.
Yeah, so instead of 300, we can simply mark the days which are the travel days as 1 and otherwise 0. So we can check in the loop that if it is equivalent to 1, then we can go to the first condition. And if it is equal to 0, then we can go to the second condition. Yeah, if this makes sense. I think it will work. I have implemented it.
Yeah, I think line 10, if day is not in days, that save a lot of memory instead of using 365. That one.
Yeah, if you guys don't find, I can share my solution.
Yeah, share it.
like if you look at this problem and the previous problem, both are like quite similar.
To a certain extent, yeah.
Yeah,
Yeah.
is my screen visible?
Let me see. Yeah.
Yeah, is it visible? So basically what I have done is that we have the days array, which is this one, and I have made a DP array which will store our answer. So it will be the maximum, the total number of, I will take the size of the maximum one, which is 10. So I have initialized it, and first I have marked the days which will be my travel days as 1, and initially all were 0, which I have filled it in it sort of, and then I have traveled all days from 1 to n, and if it is a travel day, then I have taken these 3 possibilities. Otherwise I have filled it into the last day which we are getting. So at last I will get the result, that is the minimum day, minimum value at the end of the day. So basically that is what I have implemented, if it makes sense.
Yes, but if you have only one day, and that day is 365, then you're gonna create an array of 365, right?
Yeah. So actually we need to create an array of 365.
No,
I
in
think
Shashank solution, he does not need to, because he check if day is not equal, it's not in days.
Days array.
Yeah, and then he can opt, and then it does not need to.
Okay.
Oh, Shashank is creating the DP array of size 365. The day R is 365.
This looks like, I mean, similar to coin change problem now.
Coin.
You're subtracting the amount. Okay, go ahead.
Yeah, because we are doing here in DP array, so we use the amount, and here we are using the last day of travel.
Yeah, but in coin change, we have like we have the sequence of number, the guarantee to fill, right? One,
Yeah.
2, 3. But this one can scatter, you know,
So-
only selection day to travel.
Yeah, so the same thing. I mean, you have a denomination, and here you have the days on particular days when where you travel, and the passes you can get for the 2, 7, or 30 only.
Yeah, but
So,
like
so
when you go back, it's not continuous.
but in coin change, we get the we have only one value, that amount, right? For which we have to get the minimum
Yeah, but
denomination. And here we have number of days, so we have to get the cost for all the travel days, the minimum cost for those travel days, and then sum up.
In the coin change, we have the amount, and we guarantee that, you know, from 0, 1, 2, 3, 4, 5 to that amount, you know, is there. But in here, what I'm saying is they can select any day of the year. Maybe they select only one day of the year. You know, maybe they select only out of 1 month, they only travel 2 days.
Yeah, I think here the answer is basically depending on the days, the range of days which we are covering. So in coin change, I think it never it not answer not depends on the range of the coins. Here it actually depends on the range that we are covering, sort of. But I'm
Max
not.
days what you have. The
Sorry?
max days. I'm telling it depends on the max day that you want to travel.
Okay.
Like in the first example, we had 20, right?
Yeah.
So I'm creating a DP of size that 20 first, the maximum days. I will have a size of 20 and fill it with the max cost. So it totally depends on the maximum day on which you want to travel. The max day to which you can travel.
Yeah, exactly. So it will depend on the last day which we want to travel. Yeah. So.
Exactly. Yeah. Mm-hmm.
You can you run your code, and I want to print. Can you print the DP array?
Yeah, sure. So should I print the final one or each step?
Final one is also fine.
Okay. Yeah, so it is containing basically 20 elements, I think. So
yeah, that's fine.
is it fine?
Yeah, thanks.
So should I stop sharing my screen? If there are no queries. Okay, fine.
No. So should we proceed to next?
Oh, yes, please, because we already
running out of
right,
time.
Yep.
Okay. So we have sum of subsequence which we are given an array of integers. Consider all the non-empty subsequences of A. Now for any sequence S, let the width S of S be the difference between max and min element of S. We need to return the sum of all the width of the sum of width of all subsequences of A and take the mod of this. So like 2, 1, 3. So all the possible subsequences will generate and take the difference of, like, here you'll have only one. So 0, 0, 0 corresponding to them. Here max is 2, min is 1, 1, 1, 2, and 3 minus 1, because 3 is max, 1, 2. So when you sum them up, it will sum up to 6, and these are the nodes. So any queries here?
So what was this last one, 213? How come it is 2 for the corresponding widths?
Maximum is 3. Maximum is 3 in this array, and minimum is 1.
Oh, so only max and min.
Yeah, exactly. Difference of max and min. You this one.
Yeah, fine.
Okay. Any approach in this?
Yeah, I think we can generate all the subsequences and keep the track of the minimum, and you know, and we can, like, it's a kind of brute force approach.
Yeah,
So
yeah.
we can take modulus each time, keeping track of the difference.
You don't need to have modulus because max minus min they are saying, so never you'll get min negative.
Okay. Yeah.
No.
No, but
So
the whole sum can reach to, like, the whole sum can be
Oh,
greater.
sorry. Yeah,
Yeah.
sorry. I thought modulus as absolute. Sorry.
Yeah.
So here the brute force will only work, right?
so what are the constraints, Shashank?
Constraints are like the length will be less than 20k, and the elements can't be elements will also be less than 20k.
So I don't think brute force would work because I think
You
if
can
it would
use
be
modulo.
2 raised to power 20, I think would be.
Yeah, that is okay. But if you look at the way the problem statement is, there is no other intuition, because if it is like what they are trying to go, get to that point about some mathematic formula,
Yeah, there
that is not
might
an issue at
be
all.
some. There
Yeah,
might be some actually because
math formula is there a little bit.
yeah. So like to generate all the subsequences, we have just two options for an element. Either it could be part of it or it cannot be part of it.
Part of it. Yeah.
Yeah.
So
One
you
intuition can be like the answer does not depend on the order of the elements, right?
yeah. So
So
that also.
yeah, so one thing we can think that if we sort the elements, then it could slightly optimize the brute force solution also. If you are getting what I'm saying.
Yeah.
Because we can, in that case, if when we are adding the elements, we have the like maximum and the minimum elements because the array is sorted. So in that case, we don't need not find each time what is the maximum and the minimum element in the permutation.
But again, you have to generate all the possible subsequences, right?
So
Yeah.
okay. So suppose if we have sorted it, so like it is 1, 2, 3. So 1 would be part of 2 raised to power 4. 2 raised to power 2. It would be part of 4 subsequences.
Yeah.
Yeah.
Yeah. So it would be the lowest element in of all 4 of them.
Yeah.
But we have to subtract the 1, which is just 1 is included in that. For rest of the elements, minus 1 is what we should have in the answer. 3 times, sorry. 3 into minus 1. And so this would be the minimum element, I can surely say. And if we go to the element, second element 2, it would be the
0.
least element in the 2. Suppose the index of 2 is I, and we have total n numbers. So we have n minus I elements which are greater than 2, and I minus 1 elements which are less than 2. So it would be the maximum element in 2 raised to power I minus 1 subsequences. And for
Could you share the screen?
yeah,
Type
I can
something.
share, but I'm thinking.
The way to look at it, when you sort the array, you can take the first element and then compare with all the others, right? So you can find the
Yes.
subsequent from there.
Yeah, because if you
Brute
actually,
force, actually, the better brute force.
so I'm just thinking, I'm not sure whether it would work or not, but let me. So we
But the
have
way
the
you
array
are
like this.
explaining is the right way to do. So because you have to go and find out the
Yeah, so
positions for that.
use permutation and combination logic over here.
Yeah.
So suppose if I'm calculating for the element number 7, in which it means it matters only if it is the lowest element or the greatest element in a subsequence, then only it would contribute to the result. So that part I am looking at that. So it would contribute to the result if it is the greatest element, it would be the greatest element till these subsequences. So we can generate 2 raised to the power 3. So I might make a mathematical mistake, so correct me if someone figures that out. So this is, so total subsequences till here would be 2 raised to the power 16 minus 1. We don't include the empty element, and with single element would be, let me write some,
2:4, right? Yeah, okay.
just let write some basic formula that we'll use over here.
That 3 is index or the number of elements less than 7.
So 2 raised to power n minus 1 when we don't have the empty subsequence.
He's taking
And
index.
so when we have total n elements, so what else to, also I have to exclude which has a 0 part, single element, how many that would be. So that would be just n, I think. Just include every element 1. So these are
So just,
the subsequences in which it would be.
so just
I
gonna
look,
duplicate
sorry.
values.
Yeah, but that is not going to affect the answer, I think.
Yeah, duplicate value should be fine, I would say.
Yeah, it would still remain the maximum element if I have another 7, or minimum element still, but the order, it does not matter actually. We are just considering the case whether I am including that element or I'm not including that element.
Yeah, if they would have mentioned that we have to calculate for distinct subsequences, then I think this method won't work.
Why duplicate? It's not matter. If this case we have 1, 1, 1, 1.
Yeah. So suppose we have all ones. So either we can say that 2, 1, 1 and 1, 1 both are same. But if here we are taking the subsequences, I think both of them are different. Because just I'll write if I have, I forgot. So if I have this array, so the indices are 1, 2, and 3. So I can have a subsequence includes indices these. I think these are different according to the problem statement. If they are not, then my approach won't work. These are the indices because elements are all same for this test case.
No, but your case, it should work because,
no, but then I would say that these all subsequences are same. So whatever formula I'm writing, this won't be valid.
No, because you do it both side, right? You have to do it at the lowest one, also at the highest one.
Okay, we'll handle the duplicate part later on anyways.
Yeah, because it will become 0 anyway. So whatever the
Yeah, so we'll discuss that actually. We're trying to figure
no
the
problem.
solution. So this n should not confuse by subtracting it here. So total subsequences in which element is min, so that would be ith element. Would be 2 raised to the power I minus 1, that is subtracting the subsequence with empty element, also subtracting the subsequence that are with single element. So these are the subsequence where the element would be minimum, and its contribution to the answer would be negative of
minimum one.
The value at ith index into the count that we have just calculated, in which this is the minimum element. Similarly, we can just say how
The
many?
formula, I have a question. So 2 raised to I minus 1,
Sorry. This is for the max. Sorry. Was this your confusion?
No, I think, do you want to give a bracket around 2 and I minus 1? Because it looks like I minus I is going to be get 0.
Yes, this is 2 raised to power I minus 1 minus I.
Oh, okay. Then I understand.
Fine.
Yeah.
So this is what I call is count, max, and these are the areas in which it is max actually. By mistake I wrote it minimum, and for the elements in which it would be min. So this is so similarly we can replace it with n minus I and make this negative. So I think for every element this might be its contribution to the answer, and we can iterate through every element and we can sum up these values. It might be the correct mathematical way to solve it. So any doubts in what I have just said? So you get the idea what I'm doing for the max part. Similarly, we can use that for the min part. Just replace it with n minus I, because these are the elements where it would be have negative.
Can you take a very simple use case, something like 213, and just run through it, so it will be very easy for everyone to understand?
Yeah, but I'm thinking this
Bigger one,
right.
1, 4, 6, 7, 8, 11, 3. That will
Yeah,
be
so there's one. And I'm taking these subsequences. I'm just thinking if I've left anything, like there's something more that I need to add to the answer. So, okay, I'll just iterate through one simple answer. 1, 2, 3, and 4.
Okay.
1. So I'm calculating for the 1. So this is what I was missing. So I don't have anything in the left. Maximum element anywhere. So its contribution, suppose I is 1. So 2 raised to power 1 is 1 minus 1 minus 1. So its contribution to the max is 0. I'm just zeros. The maximum. This is 0. So I will simply calculate 2's contribution to the maximum. That would be 2 raised to power 2, 4 minus 1 minus 2. Because that would only be the subsequence where it would be maximum element. Fine?
Mm-hmm.
So 3's contribution would be 2 raised to power 3 is 8 minus 1 is 7 minus 3 is 4. So I'll just write the subsequence in bracket. Contribute to it. There should be 2 raised to power 8. 4. Is there anything wrong over here? Or is there any
2's contribution to the maximum should be 4, right? You didn't multiply with the value 2.
Yeah, sorry. I'm just actually calculating the subsequences.
Mm-hmm.
Okay.
So for the 3, you have 1, 2, 3.
I have 4, but I cannot figure out which one would be the 4th. So 1,
2, 3, 4, right?
3, 4.
No. You are going the others.
No,
okay.
no.
It
It has to be the maximum element. So
So it
There's some.
will be 1, 2, 4.
No, there's something
minus
wrong in the formula, I think.
4 minus 1,
Yeah.
3.
No, it's correct. For wrong in the formula, I think something.
The formula is
Yeah, so
wrong.
I think this should be right. It will be only 3. And the
Oh.
formula will be, like if you consider each and every index, you have to have the binary value of that, right? Maybe like if it is the 0th index, it will be 2 raised to 0. The second index will be 2 raised to 1 for the second. And if you do, if you subtract the indexes, the power of the indexes with both of them together and multiply by the lowest one, or whichever the way you are actually traversing, then you will get that value.
Very difficult to actually.
You
Yeah.
you didn't do the
When you
minus 1 minus I. So 2
No, I
raised
did.
to
I actually.
no, from the 4 you have to do the minus 1, right? Or no?
No, I did it. So there's
Oh, so
something
2
wrong
raised to
in the
3.
formula I've derived. I'm just thinking it.
Yeah,
Okay, it is necessary to include 3 in the subsequence. That part I missed. I just calculated all the subsequences till here. That is what I did.
Alone
So,
3 should be 1.
Yeah, 3 should be always there. So I don't have a choice over 3 to whether to include it. I think then it becomes.
But 3 will only 3 will contribute 0 to the maximum.
Yeah, but when I calculate all the subsequences till I, then that would be 2 raised to power I. I subtract minus 1. Then I subtract. Okay, so I'll make it a little bit more complicated.
So
now for the
I is
ith
an
element,
index, right?
yeah. So when I'm dividing it by 2, you have to understand one thing, that for this element, I'm not giving the second option. So it can be 2 raised to power I minus 1. You get this 2 raised to power I minus 1. Why I'm writing 2 raised to power I? For every element, I have 2 options. So I'm counting the total ways. For one element, I have 2 options, whether to include it in the subsequence or not. So 2 into 2 into 2 into 2. But for the last element, I won't have that option. That is what I just figured it out, because I'm considering that element is the maximum, so I don't have that choice. So I don't get that option to exclude it from the subsequence.
I want to add one thing, that we have to calculate like the maximum and the minimum. So suppose if the subsequence contains only one element, and obviously it will not contribute to our answer, right? So so we should have at least 2 elements in our subsequence, right? For it, in order to have the contribution. So I mean, if we take a range, suppose like I take 1 and 4, or let's say 1 and 7 I take as the range, then my answer should only depend on 4 and 6, right? Because I already get the minimum value and I already have the maximum value. So I need to the subsequences which will be generated will out of 4 and 6, right? Because so we have choices on 4 and 2, what you are doing in 2 raised to the power I. So if we can take out the range of that, so I think that will simplify the problem a bit more.
So can you write it, because it is very
Yeah. So
not
I
much
will.
easier to figure the maths when you're speaking.
Yeah.
At least for me, it makes more sense when it's written.
Yeah. Sure. So I will just try
So
to.
I'll stop sharing and then you can.
Yeah.
Should
Sure.
I ping? Do you need any of this if you are just extending this solution, or?
No, my intuition was slightly different, so I would like to.
Okay. So I'll just stop sharing and you can start from scratch.
Yeah. Sure.
So I think any doubt in what I was trying to do, or just to the other people?
I think you are very close, so yeah.
Yeah, exactly.
No problem.
Okay, so no, there's some mistake I did in calculating the formula. So
Yeah.
I should be able to do it when I'm alone. Okay, so
No
since
problem.
he's sharing, yeah. Okay, so I'll
It's
stop
a
here.
bit tricky to understand. Yeah, that's true.
Yeah.
Yeah, I
Yeah.
think permutation combination is.
Okay, no problem. Thank you.
Yeah, thanks.
Yeah, so is my screen visible?
Yeah. Yeah.
So actually what I was saying is, wait, here is the test case. Yeah, so yeah, so basically, if suppose we have this array, let's say, so suppose we have this array and let's say add more elements in it. So 5 and 6. Okay, so I am going to sort this array first, and let's say I get 1, 2, 3, 4, 5, and 6. Okay, so I'll just take two index. Suppose I take 1 and 4, and my answer will depend on 1 and 4. I mean that my minimum will be this one, let's say this, and my maximum will be 4, right? So I will have like 2 and 3 here. So if I want to, so let's say like 2 and 3 elements. So I want to generate the permutation. So 1 and 4 I already have. Now I want to add 2 or 3. So I can either choose 2 here or I won't choose it. So one set can be this one and other set can be 1 and 4 I already have. So I can have 1, 4 and 3 here, right? And similarly, we can have the, if we include both of them, then we can have 1, 2, 3 and 4, right? Are you getting what I meant to say? Because yeah, so basically I am choosing two index. So the possible permutation which we can generate is basically it will be equivalent to, I think, 2 raised to the power the index of this minus, yeah, I'm not sure if I'm correct.
Exactly the index
Yeah,
I only.
4, right? Yeah, okay.
Yeah, so let's say
3.
we have 0 index, 1 index, 2 index, 3 index, 4, 4. So I have taken 0 and 3, right? So it will be like kind of 3 minus 0 minus 1, because so we take minus 1 because we are getting 4 subsequences out of it. Did I miss any sequence? Yeah, I missed 1 and 4. So it will be 1 and 4. So I am generating 4 sequences out of this range. And in that particular sequence, 1 will always be the minimum and 4 will always be the maximum.
Oh, you did the rightmost index minus the left index minus 1.
Yeah, yeah. So it will
So,
be like, basically this
but
formula denotes the total number of subsequences. And in this, always the
1 and 4 would always be there.
yeah, so
The
it will be
elements 1 and 4.
yeah, it will always be like 4 minus 1. So we can simply multiply them.
Yeah.
So this will be the contribution of that range.
Yeah, so it just
This
4
was I
is
meant to
2,
say.
3.
so you have minimum 2 elements, so you need not worry about subtracting those cases
Yeah,
like empty or the with just one element.
yeah, exactly.
And you are having plus and minus contribution at the same time.
So yeah.
So will this be an n square? That is, you identify all these ranges, for example, 1, 2, 1, 3, 1, 4, 2,
Yeah,
3, 2, 4.
yeah, it will be n square, and I tried it. Then it was coming TLE. So then, honestly, I have to check into the solution. Then I found out that they are deriving some formula out of this.
Oh,
So
from this as well, there is another formula. This
yeah,
actually looks very well intuitive. Thank you for sharing this.
yeah. So it makes sense. The formula, if you want to go through, I can just share with you. So this is the derivation which they are doing actually here. This one.
But in this case, when you are taking just this 1 and 4,
Yeah.
so what will be the answer? Like only for 1 to 4, okay? So it will be 9, right?
It will be like 2 raised to the power 2, which is 4.
Oh yeah, forget about the formula for time being. If we just calculate here,
Yeah.
so it will be 3 in the first one, and then the second two also will be 3 plus 3, right? That will be 9, and then okay, it will be 12, right?
Yeah.
So then you have 2 raised to 3, which is 8, and minus
2
1.
raised to power 2, 3 minus 0 minus 1.
So I can write a bit generalized formula, like if you want.
Yeah, so if you
Yeah, it will be basically, if we choose a range j and I, then it will be 2 raised to the power j minus I minus 1 into the values of a of j, because it is sorted. That's why it's not a problem.
So do you really want j minus I minus 1? Minus 1 is really required, or?
Yeah, it is actually required because
It depends on the implementation. If you are iterating from one index after the right.
No, actually,
it's required.
So the case where I also stuck that I was getting 3 only, it because it mandates your subsequence would always have the element 1 and 4. Then only it can be maximum minus. So you lose that. You have to subtract minus 1 from there. So you can you only have options over the in this case. If you go to till element 1 from 4, so 1 is guaranteed to be in the subsequence. 2 for element 2, you have an option whether it can be in the subsequence. It can't be. So 2 into, again for 3 into 2. For 4 you don't have an option. So that is why you have to 2 raised to power 2. You
We
cannot
have
have 2
two
raised to power 3.
possibilities at each element between that range.
Yeah. So for 1 and element 1 and 4, you don't have that option. You have to include that into the answer.
Because they are max and min, right?
Yeah.
So just for an example case, if we take just 1 and 2, and by your formula, like 2 raised to j minus I will be?
Won't have any option. It should be just 1.
So if you, no, I'm saying the 1 and 2, which has index 0 and 1.
Yeah. So it would be 1 minus 1. 2 raised to power 0. That would be 1.
So that will be 1, right?
Yeah.
And then aj minus ai will be 1. So that will be 1.
Yeah, so it finally like breaks it into how many elements between them are there raised to power that. Because those elements we have an option whether to include them or exclude them.
Okay.
For the corner elements,
makes sense.
It is mandatory. You always need to have them in the sequence. So
Array,
since there are no elements between 2 and 1, there's only one option, that is 1 and 2.
Yeah.
So that was the mistake I was doing.
Yes.
Okay.
So, but what is the like final accepted solution? You're saying this is also not getting accepted.
Yeah, actually, the final accepted is that they have derived it. Actually, they have broken it into two separate summations.
Yeah, actually, the one I was doing was it was O of n. It wasn't n square.
Oh.
Yeah, so I wasn't iterating through all the elements. For every element, I was calculating in how many subsequences would it be the maximum element, and how many it would be the minimum element.
Yeah, but how will you track in your like? How are you tracking the minimum and the maximum element in your code?
I think he's only taking care of max, not min. Because you should have taken care of min also, and then go ahead.
You have to take care of both. I think.
No, for taking the min, I have to consider the just right part of that.
That you were
Suppose
not
if
doing.
I just wrote over there that it is similarly I'll have the positive contribution and the negative contribution.
Okay.
I did not explicitly write that. I just asked whether it is clear. But even like I have to run and see if there's any mistake.
You can share your solution. If it gets passed, it would be nice.
Yeah, if it gets passed, I will definitely share.
Yeah. Should I stop sharing my screen?
Yep. No problem. Yeah, thank you.
So it's based on the same intuition, but the formula that they were saying. So same thing, like I mean, I'm taking care of this max and min. Whenever you find max, how many possible subsequences you can generate, you take the index of that particular element, 2 raised to the power I. Let's say if you want to array is sorted as 1 to 3, and if you want for 3, then 2 raised to the power the index of it is 2. So these are the 4 subsequences that you can get, in which your 3 will be the maximum, in which you'll have a of I as the maximum: 3, 2, 3, 1, 3, and 2, 1, 3. And its counterpart for minimum, you can take the total length of the array, subtract 1, because you don't have for the extreme elements min and max, you can't. And I think Leon can.
9641.
Can someone mute everyone?
Leon is, I think, not unmute.
Yeah.
No, but the host can mute everyone against.
Yeah. I'm checking where's the option for that.
Okay.
He's muted himself.
Yeah, we are good. Okay, go ahead.
Okay, yeah. And for minimum, you'll have the length of array -1 and minus the current element which you have taken, subtract that, and you'll get this 4. So if I take 1 as a for 1 as a minimum, then you'll have these all 4 possible sequences. Now I had all the count is 4 into value I'll multiply, like for 3. So you can have 1, 2, 3, 4, 4 into 3, 12, and 1 into 4. Sorry, this is for 1. So 1 into 4 will be 4. So 12 minus 4, 8.
Oh, so you take for the minimum and as well as the maximum, and then when you subtract, you get the real one.
Yeah, exactly. So for doing that, I just did the left shift. I mean, you could have used mat.power also, the power function, but this is much more faster compared to all the exponential functions. So just I sorted the array first, and then while iterating through the array, just this is for calculating the number of sequences that you can form given AI is the maximum. So let's say 3, corresponding to 3, you'll get 4 and multiply it by this value. So all the maximum you'll get as 12, it will be 12. And for this remaining will be what? The total length of the array -1 and this minus I, the current sequence, and multiplied by its value, and then just subtract them and just append the result. Once you accumulate it, just get the mod of it.
So is this accepted? Because this looks like similar to what previous 2 guys were saying, right?
Yeah, it's similar based on that intuition only. But I think they were having.
I was trying to do the same thing, but my formula was coming different, and I don't know why this 2 raised to power I is working, because like 2 raised to power I would include all the subsequences.
Yeah.
Where that is, but there are subsequences where that is like it is the subsequence with just one element, and there is a subsequence it does not include any element. It's just empty. So
you got this intuition why -1 and minus, right?
Yeah, this is clear. The first one I'm saying, when you're just having the
like
because I was also doing the same thing.
Yeah, exactly.
It was just my formulas are different, and I'm just figuring out how they are correct.
This is same as 2 ki power I. I mean 2 raised to power I.
This is 2 raised to power I, but
and this is 2 raised to okay. So
when you say 2 raised to power I, that means it has all the subsequences till I. I elements, including means there's it will have subsequences with just one element. It will also include a subsequence where there's no element present.
Exactly. Subset
for
and empty set also it will.
Yeah, for there won't be any contribution by num.
For
That is,
empty set and the single element will have no contribution.
Yeah, so those I was subtracting, but here you haven't subtracted it.
Excuse me, what are you subtracting? Can you just tell in, suppose in a sequence of 1 to 3, and I have indexes from 0 to 2. So what are you subtracting this part? What are the
Yeah,
subsequent?
so there would be a subsequence which just have 1, 2, and 3. Just element 1, just element 2, just element 3. So these would have 0 contribution as per the test case given.
Yeah,
as well as the
no, I am talking about in this solution that result minus equal to.
Initially, what will you have the result as? So total number of subsequences 2 raised to the power 2 raised to the power I. I mean, for let's say for max, I'm calculating 3 is the max in your array, right?
Okay.
And corresponding to that, the index is 2. So you'll have 2 raised to the power, something power like this. 2 raised to the power 2. This will be equal to 4. Now total number of subsequences in which 3 will be maximum is 4, and how much it will contribute will depend on its value. I mean 3. So total it will contribute is 12. Now 12 minus, you have to calculate all the subsequences with 1 as minimum. With this this number will be there, and minimum you need to have. So for that, what you can have, just n is what?
Yeah,
2 raised. Okay.
Yep.
So I think it might be possible that you are adding some extra in the line number 10, and then similarly that is getting subtracted in line number 13.
Yeah, that is what the whole thing is. Yeah.
Nullifying each other.
Yeah, it might be like you're adding some extra stuff in line number 10, and that is just getting subtracted in line number 13.
Because here also I'm allowing single elements, and here also, so they will.
Yeah, okay. Ideally, because so in the cases which I was saying, that there would be just empty subsequence, so that you are adding over there. Similarly, there would be an empty subsequence in line number 13 that you are subtracting. So that is definitely getting cancelled out.
Hey, Shashank, can you complete your thought on line number 21? That is, what were you subtracting?
Yeah, sure. So what you'll do now, corresponding to this num as 3, 3 is the value, and you have to generate all the possible subsequences. So 2 raised to the power n is what? 3. 3 minus 1. Sorry. Let's say this is PO. Okay. So 3 minus 1. A minus I. Minus I initially is 0. So it will be 2 raised to the power 4. Sorry, 2 raised to the power 2. That is 4.
No, I is not 0 there, right? I, you are taking the last one, right?
No, I'm going from.
See, if you take 2 raised to power 2.
Sorry.
Yeah.
I was going from initial. I will be your 3.
I will be 2, right, in this case.
Sorry, 2, because 0, 1, 2 it is index. So
Right.
it will be your what? So it will be 2 only, right? 6 it will be. 3 minus 1, 2, 2 minus 2, 0, and 2 raised to power 0 is 1.
Right. 2 raised to power 0 is 1. So 3 into 1 will be 1. So 12 minus 3 will be 9.
3 into 1 is 3. Yeah, it will be 9.
So that is what 9 will be, right? If you look at the answer.
Oh, I see. So basically here, what exactly you are doing? You are just taking out the contribution of 3 individually, like 3, if in the first calculation on line number 10, if you would have taken just 3 as a set by itself, you are just removing that contribution?
No, it will. It is getting removed in the second part.
Yes. Okay. But here, when we created the sets for 3, which are the 4 sets which has 3 as the maximum.
I'm sorry. Actually, it's not going to be 4 into 3. That should be 3 into 3. The first, what you said. The answer should be 6, actually, right? Not, see, if you see why you are taking 4. It's not. It should not be 4, right?
Oh, element is 3, right? Yeah. should be 9 and 9 minus 3 should be 6.
Hold on, I'm confused. So 2 to the power 2 is 4, element is 3. So you are computing 4 into 3. What was wrong there, Santosh?
Element I was taking here as 4. Element I was taking as 4. It was actually 3.
No, you had 2 raised to power 2 equal to 4. Hence you had written 4 there, and the number was 3.
Okay. Okay. So,
No, it was.
So yeah, the 4 came because 2 raised to power 4. So can you just go up on the result, the first one?
First.
So how does your I, the line number 10, how does it come
Let
to?
me start from beginning from start.
Please,
Let's say I initially I is 0, right? And your num is 1.
Okay.
Okay.
Yeah, I think I was just giving example in mid. That's why it was getting
Right,
confused.
yeah.
Now, what will result be? Sorry, result. How many subsequences you can generate with 1 as the max? So for that you will take this 2 raised to the power. See, 1, this 0. This will be equal to 2 raised to the power. Let's say power 0. 2 raised to the power 0. This will be your 1. Okay, into num you will do. Into num is what? 1. So it will contribute 1 to here. And now for that minus part, now this is when 1 is maximum, how many subsequences you can generate. Now when 1 is minimum, what you'll generate is 1, this, n is what? 3. 3 minus 1 minus 0, sorry, minus 0. So 3 minus 1 is 2, which will be equal to 2 raised to the power 2, which will be 4. 4 into the element 1, which will be equal to 4. So 1 minus 4, it will result as minus 3. This is the first iteration.
Okay.
Yeah, got it. So I think for each element you are checking when that element becomes the maximum, how many subsequences will be there, and then when that element will be minimum, how many subsequences will be there, and that is how you are adding and subtracting the contribution.
Accumulating. Now based
Makes
on this
sense.
result,
Yes.
again I'll go. So I'm not taking care of like single element or empty subset. All this, they will balance each other inside. You explicitly, I'm not taking care.
Yeah, because I think the 1 would be maximum only when there's one element, and its contribution should be ideally be 0, but you are taking it still. So
yeah.
No, so what does minus 3 is signifying?
So
where?
So the minus 3 actually he's doing it for the first element, okay, and he's taking the minimum. So now he'll have to go for the second element. In that case, it is 2, but it is the middle element, so it will cancel out. So if he can go directly to the last element, so in that case, it will be, the answer will be 9. So 9 minus 3 will be 6.
6.
So the 3 will actually again take 1 as a minimum, and then it will calculate the positive side of the whole thing. And therefore, this minus 3 will be subtracted from that 9, and then you will get the answer 6.
Okay.
Till now, taking 1 as a max and min, you'll have width as 6.
Okay.
So even when he did for the I is equal to 0, if you do it exactly for I is equal to 2, which is the third one, the third value, then actually you will get 9 in that case.
Okay.
Because now you are looking from the higher side, but you are taking the minimum as 1.
Yeah, I understood.
Yeah.
Yeah, basically they have derived this thing out of what I was explaining. So now I think this intuition is also fine.
Yeah, it's very difficult to understand. So you guys were explaining, it was really good.
Actually, we need to subtract those subsequences in which because they will be all counted. Yeah.
Yeah. Yeah.
Thanks, everyone.
Thank
It was
you.
great
Thanks.
discussion.
Yeah, it was great.
Yeah, thanks.
Thanks. Bye. Bye, Shashank.
Okay. Bye. Bye. Bye, everyone. Thanks. Okay. Stop the recording.